We'll move on, and Roland, I did see you in the group. So Roland, you're up next with your bring your own plugin management middleware for programmable science. And I think Abe is actually going to start the video as this is pre-recorded, and then we'll. So I don't have to time this one because it's pre-recorded, and I assume that it's right at 12 minutes. So we'll have questions for Roland as soon as this video finishes up.
Hi everybody, I'm Roland Ruche, and this is the Bring Your Own Plugin Management Middleware for Programmable Science Gateways. The agenda today is that we're going to go through the introduction, the background on Science Gateways, present our solution approach, present the Science Neural case study, and our conclusion. Research today involves working on bold problems that require solutions that are multidisciplinary in nature. Recent science and engineering research tasks are increasingly becoming data intensive and relying on workflows to automate integration and analysis of voluminous data to test hypotheses. So the question is, how do we cater these requirements to non-computing experts and bridge knowledge gaps? Science Gateways provide web-based portal interface to integrate scientific tools and data sets with domain-specific user interface customizations to help researchers and educators. They provide add-on features that can be customized for the execution of workflow and algorithms, and automated analysis of voluminous data on distributed infrastructure and cloud resources. The tools are evolving, new data sets are rapidly emerging, and the complexity of interdisciplinary collaborations is increasing. Hence, there's a pent-up need for user interface guidance and workflow content-based training for Science Gateway users. To fully utilize Science Gateway capabilities, researchers from interdisciplinary domains are required to learn how to use fast-changing technology and navigate new data sources. Researchers require guided knowledge discovery at various levels to accomplish their research/education tasks. Provide guidance on using publications, tools, data sets, and cloud resources, and required learning platforms to train next-generation expert professionals to learn, apply, create. Provide training using learning modules, pre-configured cyber infrastructures, and technical materials. As for our solution approach, existing Science Gateways with predefined workflows and interfaces and using fixed cloud resource infrastructures need to be transformed with modularity, decoupling Science Gateway application code that enables the addition of new services to operate independently but interconnect. The extensibility, the ability to easily integrate plugins, example recommender systems and execution pipelines involving AI, ML, and NLP algorithms. The scalability, the ability to deploy or run new plugins over federated local and multi-cloud resources, and the programmability to help program, register, and upload components into the existing setup using customizable interface. Previous works state the need to improve Science Gateways. The working one provides a software suite to compose, manage, and execute large-scale applications and workflows on computational resources. Provides component interactions that are handled by web services. 2, supports the design and deployment of multi-cloud applications. It aims to optimize and customize the workflows of Science Gateways. The working 3 leverages a popular Galaxy system for application hosting and workflow execution. It services for data transfer, user and group management, and authentication. It also provides elastic provisioning models specialized for public cloud resources. 4 is a framework that enables quick clients and servers to dynamically exchange protocol plugins. pQuick exposes functions as APIs for plugins. While these works seek the need to improve Science Gateways, they largely lack the capability for users to customize programmable plugins. Plugins require modular programming to maintain and deploy heterogeneous components. Our work focuses on the implementation of a multi-layered RESTful web service architecture for component interactions. Our middleware framework allows highly portable and reusable building blocks in next-generation Science Gateways. As for our solution design, we've integrated the Bring Your Own Plugin Management middleware onto a case study that is an end-to-end framework that provides management plugin capabilities for administrators and developers. The plugin management middleware provides many benefits. One, it enables administrators and developers to modularize the plugin services used to develop microservices and Science Gateway applications. So we see that it supports plugins to independently operate by decoupling processes as microservices. It supports customizable design and deployment to augment scientific workflows. So we've containerized to construct deployment patterns across distributed resources to optimize those predefined workflows in science gateway domains such as neuroscience and bioinformatics. It also provides the flexibility for disparate code bases to be integrated through microservices. So therefore, it allows developers to use their preferred coding languages when they want to be able to create customizable science gateways. In light of presenting our SciNeuro case study, we show the OnTimeRecommend system. It's a novel recommender system prototype that comprises of several integrated recommender modules. It's integrated with SciNeuro, which is a science gateway domain for neuroscience users to guide researchers for the ongoing research. Vidura Advisor is embedded with the OnTimeRecommend as a context-aware chatbot that provides guided user interface with a step-by-step navigational support using AI and ML tools. The OnTimeRecommend user interface provides a central resource hub with web interface to provide guided user experience to domain Science Gateway users. The recommender user interface provides recommendations through RESTful web services on various resources, which include tools, datasets, and expert cloud resources. It also provides a content-aware Vidura Advisor, as I previously mentioned, that provides intelligent guidance using Google Dialogflow and its Vidura services. With the Bring Your Own Plugin management interface, it provides the ability to add and manage recommender modules using plugin processes that are implemented as microservices. This is an example of the SciNeuro Science Gateway domain that is used with OnTimeRecommend. The Bring Your Own Plugin management, the plugins are implemented as recommender modules, as shown here. The plugin management integration for the OnTimeRecommend encapsulates 5 different recommender modules. The first one is the domain-specific topic recommender. So therefore, it's able to guide novice and expert users towards identifying tools and data sets that are generally used in scientific domains. The publication recommender finds relevant publications is essential for the researcher who must cope with the exponential increase of scholarly material. The Jupyter Notebook, it decimates code and improves the science productivity by appropriate notebook suggestions. The Workflow Template Recommender suggests CI templates according to the research requirement to run certain algorithms. And lastly, the Scholar Finder finds relevant scholars who are suitable in accomplishing a research task across a scientific domain. We use this plugin management middleware in the SciNeuro case study to show a series of steps. Step 1 is to register different recommender modules in OnTimeRecommend using a plugin registry. Step 2 uses the plugin workflow manager to register scientific plugin processes to execute relevant recommenders on the OnTimeRecommend. Step 3 is to add a Science Gateway client and link the recommender modules with the client to allow users to use recommenders on their Science Gateway interface. Step 4 is to configure the parameters of the recommender processes and queue the processes of the recommender modules for a specific Science Gateway client. And lastly, step 5, we execute the recommender processes using provided configurations and publish recommender outputs to end users on their Science Gateway interface. As for the conclusion, we propose a plugin management middleware framework to implement recommender modules for customizable Science Gateways. We showcase how OnTimeRecommend case study can be used to configure relevant recommenders for Science Gateway users, in this case, Neuro, to perform knowledge discovery. The plugin management approach can be generally applied to extend and scale the Science Gateways through a series of integration steps that are supported by our middleware through a web application. And the next generation of Science Gateways can be a one-point solution by featuring a guided knowledge discovery at various levels to accomplish research and education tasks for Science Gateway users, and learning platforms to train the next generation of expert professionals. As for future works, we plan to develop additional plugin support features in our middleware for, one, the integration of chatbots for guided interfaces, and also the knowledge bases for intelligent data analytics and other science gateways, which include bioinformatics and health informatics. Thank you for your time.
Okay, thank you, Roland, for that pre-recorded presentation. Are you here to field some questions? You are. Okay, I see you there. Does anyone have any questions for Roland after the presentation?
Hi, Roland. Yes, I do have a question. Your presentation sounds very interesting. I was wondering, what is the status of your proposed framework for the pluggable middleware?
Yeah, hi, nice to meet you. Yeah, so the status right now for this project is that we're still, we're currently using what we've applied to the, I guess, the neuroscience science gateway domain, and we're looking to actually scale out to other domains. So I think, as I mentioned in the future works, we want to be able to apply our knowledge of using a plugin management middleware framework to other science gateway domains such as bioinformatics, and also for the recent for COVID-19 for immunologists and healthcare professionals. I think we feel the need that as next generation science gateways are improving, we're able to find ways to manage that and provide feasible solutions for administrators and developers so that they can actually use it for various domains.
Okay, thank you.
So Roland, if someone has a recommender code that they're interested to bringing to your environment, are you at a point that you're accepting kind of external codes and getting involved with use cases from external partners potentially?
We are in the, I guess it hasn't been necessarily in the works of actually using or implementing, recommender modules or code from external partners. I think we're more so in the talks of getting that ready. There's definitely one thing that I haven't really addressed necessarily in the presentation, and that's kind of just the authentication for users to use our service. I think that's something that we are currently looking into to implement, as well as a few other things before we can actually get fully involved with external partners.
Sure. But is the goal then to finish up that authentication and the pieces and then release to general public for recommender modules?
Yes, yes.
Okay. Other questions anyone has?